When I first learned the trig identities in school, I wondered where they came from and why I should believe that they're true. I was never given a proof. We just kind of stated stuff like the compound angle formula, and we were expected to use it without justification. Well, I want to go through a picture proof of that today, and we're going to be drawing some triangles to see if we can prove this compound angle formula for sine. So this formula has something to do with adding two angles together. I'm going to choose two positive and relatively small angles, but you can have fun trying to figure out how this extends more generally. So let's draw a nice triangle here. And it's going to be a right angle triangle. And we're going to split this angle not in half, but into two. So we're going to call this angle down here A and this angle B. So of course, the sine of A plus B relates this side, which is the opposite side, to this hypotenuse. So I'll draw this in pink here. The opposite over the hypotenuse is the sine of A plus B. Okay, but I want to relate this to the angles A and B. So what I'm going to do is extend this triangle with angle B out to be a right angle triangle. So maybe something like that, where that's meant to be a right angle. Okay, so now I can talk about this triangle with angle B. And actually, since I want to relate this triangle to the triangle with A, I'm actually just going to extend this one a little bit further. So let's see what we can observe here. So one thing I notice is that this side right here, this line segment in purple, is a hypotenuse for the larger triangle with angle A. And it's also the adjacent side of this right angle triangle for the triangle with angle B. So maybe there's something that we can do here to cancel some stuff out. So I'm going to look at this side, and let's call this X. And let's call this S, maybe. So if I do something like multiply, or let's look at sine of A should be X over S. Okay, that's fine. But what about the cosine of B? Cosine of B also relates to S, and the adjacent side is now S, and the hypotenuse is this H that we're interested in. Okay, but I can see that if I multiply these two, so sine of A times cosine of B, I can get some cancellation happening here. So let's see what's going on here. So we have our S's, we have our H, and we have our X. So I notice that I can actually just cancel these S's here, and I get X over H. So it seems like we made some progress, but I'm trying to figure out what the side length O, that orange side length is. And I've only really found out what X is. But we're closer than we think, maybe. So what if I just kind of transpose this line over here, and I look now at this line segment of this smaller triangle here, which I'm going to call Y. So right off the bat, I have O is y plus x. Okay. So maybe if we can figure out y, then I can figure out O. But this seems at first glance like a difficult task because I have no idea about this triangle. But we can use some logic about similar triangles. So, for example, I know that this angle is 90 minus A, which I'm going to call theta. So this angle is theta. This small little angle is theta because it's the opposite angle at an intersection like this. Okay, but now I have a 90-degree angle here and a 90 minus A here. So that tells me that, in fact, this angle is A. Huh. Okay, well, that means that if I take a look at this hypotenuse now, and remember this is the right angle triangle now, then I can say that cosine of A is equal to, so let's give this another name. Let's call this Z, is equal to y over Z. But Z is actually the opposite side of that triangle that with angle B. So in fact, we can say that sine of B is Z, which is the opposite side, over H. Ah, okay. So what if I multiply these two together? So that means that cosine of A times sine of B is the product of these two. So we have a y over Z and a Z over H. And then, of course, we see the same cancellation happening over here. So I just end up with y over H. Ah, but if I add these two together now, I see where I'm getting. So sine of A times cosine of B plus cosine of A times sine of B should be what? It should be x over H times, oh sorry, plus y over H, or we can write that as x plus y over H. But we said above here that that's actually just O. So that's just this orange opposite side over the hypotenuse, which is H. And of course, that is sine of A plus B. So that's a nice little visual argument. You can figure out how you might want to adapt it for negative angles or larger angles, but it's the same logic. I'll leave you to prove the cosine compound angle formula for yourself. It actually uses the same diagram. So you can stare at this diagram a lot and try to do something similar to what we just did and try to derive the cosine compound angle formula for yourself.